Hello. As you are aware, I am Luke Andrew, and I am the product manager of AutoPIPE. I have been in the engineering field since 2007, working at fertilizer production plants, nuclear waste treatment and fuel production facilities, and oil and gas refineries before joining Bentley. Some of you have heard of AutoPIPE and some may not. We do provide a 30-day trial. If you want to give AutoPIPE a try after the presentation, I will share a link later on that will provide you that trial. And don't forget, we do have a YouTube channel as well that you can subscribe to and view videos demonstrating in more detail what we are discussing today. We add videos to that channel on a regular basis as well to keep your interest piqued. Today we will be discussing the top 3 ways to improve your pipe stress analysis if you are using a competitive product of AutoPIPE. We are going to be discussing AutoPIPE's load sequencing nonlinear analysis, AutoPIPE's unique integration with STAAD and SACS, and the market-leading capabilities of AutoPIPE's buried piping module. So let's jump right in. ASME published the book Pipe Stress Engineering by L.C. Pang and Alvin Pang, which stated that the analysis method used by many pipe stress software packages was incorrect, and that the only valid method was used by programs like AutoPIPE. This book mentions there are 3 approaches to handling the nonlinear analysis. There is the general straightforward approach that many general-purpose FEA programs like ANSYS and Abacus use. There's the algebraic subtraction method, which many of our competitors used, and the operating condition approach, which AutoPIPE uses. The authors only recommend the operating condition method like AutoPIPE's because it meets the code philosophy and requirements, where the other 2 methods have flaws. The total load approach, or the algebraic subtraction method, doesn't understand boundary conditions and how the bearing force can change with the direction of the pipe movement, which can possibly double the stress load range. For example, the magnitude of the friction force as the pipe returns to ambient conditions after an operating condition will be the same magnitude but in the reverse direction, and this could possibly double the stress load range. It is preferable to perform an incremental analysis, as is done in AutoPIPE, to ensure no extreme load is overlooked. In a nonlinear analysis, the sequence of loads is important. The principle of superposition does not apply, and therefore the starting point for a load case is important. The following is the default load sequencing in AutoPIPE. Gravity is analyzed with no initial state. Thermal load cases are analyzed with gravity as the initial load case. Pressure load cases are analyzed with the corresponding thermal load case as the initial load case. And then the occasional load cases are analyzed with gravity as the initial load case. Next, we will discuss the importance of including your structural steel model in your piping model for more realistic models. You can become more efficient in your design process using tools that you have at your disposal today, but perhaps not yet getting the most of them. To illustrate, we will run through a common design process where structural and piping designs need to be performed on a project, and thus requires the skills of different engineering disciplines who typically only communicate with paper documents. That results in a significant lag as the information is packaged, delivered, interpreted, and entered into the 2 systems. Using STAAD Pro or SACS with AutoPIPE, we can cut out the delays caused by this document production and bring the teams closer together, getting a better understanding of the different disciplines and address the issues that might occur on site, which could have had serious financial implications. Typical industrial projects are driven by EPCs who have appointed a design team to deliver installation in an existing brownfield site. The design team may be in-house but separated across multiple offices, countries, or even regions. Even working in the same building, it is not uncommon that the structural team has very little daily contact with the mechanical team. With this, This is the only part of the overall construction and operation process. We are focusing on producing the most accurate design quickly so that materials can be ordered, constructed, and the site can be operational with minimum of delay. So we have our team of the best professionals we can hire working to the same goal, but who can almost be considered and isolated in their own world, delivering their part of the project with only communication as being documents produced by their applications such as P&IDs or general arrangement drawings. Traditionally, these would be paper documents or maybe formatted in some digital document such as spreadsheets. These then get handed over to the other team, who have to interpret the data and apply some judgment and enter it into their own system. This is slow and cumbersome, and we can be far more efficient. As projects and organizations get bigger, this practice of working in isolation becomes more pronounced and more of a burden, which is made worse by an approach of maintaining the same traditional process that was used in previous projects. When pressure is put onto teams to become more productive to reduce costs, get designs complete quicker, and get sites up and running sooner, there are two approaches that can be taken. Either take the existing procedures and try to find ways to make them less cumbersome, or I would suggest that the smarter approach might be to find another better way to achieve the same goal, considering that the changes have occurred in the world since the procedure was developed. Teams often work in isolated silos, as if there was a barrier between them. This wall may be real or virtual, but basically neither team is getting the best from working with the other team. But if we remove this barrier, there are real opportunities to make your work easier. With the approach shown here today, we are providing each team real value in working together. We recognize that the analysis and design requirements of both disciplines is specific, which is why they have specific models and different analysis tools. But they need the same underlying data, just processed individually. By sharing the data with our bidirectional data exchange, the structural engineer can locate the forces from the pipes without having to rely on pipe stiffness for stability. This can be done much faster than trying to work through and interpret possibly hundreds of printed documents. The piping engineer can include the actual flexibility of the supporting structure to get a more accurate analysis of the stresses that develop around nozzles, which can have critical effects. So let's take a quick review of the benefits of the process we're discussing. This integration has the ability to transfer the piping loads to the structural design model as well as the structural steel back to the piping model. This allows for the creation of fully connected piping and structural analysis models. This can be done with single or multiple structural models and single or multiple piping models. This workflow allows for a better 3D visual coordination and allows for 3D clash detection under hot and cold deflected conditions. Starting with the piping geometry, in AutoPIPE, which can be imported from a 3D CAD program like OpenPlant, we perform a preliminary analysis to position the pipe supports. In structure from ISM or a 3D CAD program, or model it from scratch. Then it's not a magic trick. We simply import the piping geometry into STAAD to show the location and the type of piping supports as our first 3D visual coordination check. We export the structure back to AutoPIPE and automatically connect the piping supports to the structure. In AutoPIPE, a combined analysis is performed that more accurately includes the structural stiffness and weight. We transfer these more realistic piping loads back to STAAD, which are automatically applied to the structural model, saving hundreds of hours of manual data entry. The STAAD analysis and design of the steel structure with the actual piping loads is concluded. We now have completed out weeks, using more realistic design models with potential cost savings and dramatically improved risk mitigation. And we will round out our conversation today with a discussion on buried piping. AutoPIPE's buried piping module is recognized by ASCE. Long ago, we added an automatic soil stiffness calculator which calculates the soil stiffness values for the user. AutoPIPE reference information also provides the guidelines for the calculations on getting the soil stiffness properties of typical soil types like sand and clay in 4 different directions. We currently have 4 methods to get these values automatically calculated. We have the AutoPIPE method, which is based on reference information and calculations as outlined in our AutoPIPE help content. We have ASCE 2001 with the 2005 addenda based on the information from Appendix B, soil spring representation of the guidelines for the design of buried steel pipe by ASCE and ALA. And then we have the PRCI 2009 method based on the Pipeline Research Council International's methods. And then the final method is the user, which allows the users to manually calculate and enter the soil stiffness properties. AutoPIPE has the capability of having 3 sets of soil stiffness properties calculated for static loading, low, high, and average. The exact value of what the soil stiffness values can be are difficult to calculate because of their nature of the soil and the way the properties vary with seasons and changes, so we take an upper, a lower, and an average limit. AutoPIPE also has the capability to analyze for 3 sets of soil stiffnesses for dynamic models. Our competition cannot analyze dynamic loads for buried piping and has convergence problems. AutoPIPE can handle modeling and analysis of buried piping systems with nonlinear properties defined. The soil supporting a buried pipe may provide nonlinear support, either softening or stiffening, as the load of the soil increases. AutoPIPE allows nonlinear properties to be defined when creating the model. These properties can be considered or ignored when the model is analyzed. Separate properties can be defined for longitudinal soil resistance, representing longitudinal cohesion, for transverse horizontal resistance, and for transverse vertical resistance. In the vertical direction, different properties may be specified in the upwards and downwards directions to account for differences in uplift and downwards bearing behavior. The user is able to control the spacing of soil springs inserted by AutoPIPE by modifying the soil spring spacing. This is important for the user to be able to define soil springs at closer spacing where a change in direction occurs, i.e. at your bends and tees. The soil spring spacing can be increased as the pipe moves away from the bends and tees until a virtual anchor length is approached, after which the soil springs may no longer be required. We have new advanced soil loadings and analysis for that are according to ASCE and ASME rules. The soil weight above the pipe is included in this, traffic loads, seismic wave propagation, and building settlement. Let's run through a quick example showing how the soil properties are defined. So we're first going to the soil settings of this vertical section of pipe. So we get the pipe selected first, then we're going to insert the soil properties, then click on the Enter Soil Properties button. And we're going to see our options for the soil property calculations. Then we'll see our different soil types. With our selections, we can generate our properties. We can also modify to whatever we desire. And then for the vertical set, we're pretty much okay there. And then we're going to select our horizontal pipe. Use our input grids to make that selection easier. Then we are going to insert our soil properties again. Again, we have our different calculation methods for the different soil types. And we will generate those soil properties. And then we can again vary our soil springs based on our virtual anchor length settings. And then we also have the soil live loads like the airport and traffic loads and different fill types. And at the very end, we can enter in a maximum soil spacing limit as well to give us even more control. And to review what we have discussed today, we've talked about the load sequencing nonlinear analysis that AutoPIPE has that meets the ASME code philosophy. We've got our stellar structural model integration that AutoPIPE has with STAD and SACS, and the buried piping module that AutoPIPE has that provides many great capabilities. Be sure to check out bentley.com/AutoPIPE if you want to get our free 30-day trial of AutoPIPE. I have also posted the link to our Bentley community online forum. If you have any questions about AutoPIPE, you can ask them there, and you will get a quick response. And as mentioned before, we do have a YouTube channel that I suggest you subscribe to in order to view some of these functions that we presented in more detail. You just go to YouTube and in the search bar, search for Bentley pipe stress analysis. And now we can open up the room to questions.
Okay, Luke, we have some questions coming in here. So starting with first question here, how are structural steel flexibilities included in the AutoPIPE model?
So basically what's happening is the steel is modeled within AutoPIPE with the flexibilities that the steel has, and then those pipe supports are attached to that steel, connected to or attached to, kind of the same thing. And then when that pipe support is pushed by the pipe, then that support is then now pushing against the steel itself using the flexibilities from the steel.
Okay, great. I have another question from a user. How does the nonlinear approach affect the loads and the results?
So basically, there's the two different methods, and those methods are described in that book, Pipe Stress Engineering. And if you really are interested, you can send me an email, and I can send you some sections from that book posting those arguments. But basically, the total load method, or the algebraic subtraction method, just basically finds the entire results, and then it subtracts out what it doesn't want to see from the results. Whereas with AutoPIPE, we analyze all the different load cases, and then we apply those load cases on top of each other, providing a more realistic, real-world solution.
Okay, let's see, just scrolling through. I have a user question. How can I input the soil overburden loads in the Edit Soil Properties input box?
So basically, there's a soil overburdens button on that soil properties dialog, and once that dialog's open, it's pretty self-explanatory. And if you have any issues, you can go through the help content to describe what all the different inputs are and all that. And then if you still struggle with that, you can post some questions on the communities forum that I have posted there.
Right, and just to add to that, the soil overburden loads, you can input soil overburden loads for only certain codes in AutoPIPE currently, so you can use the help menu to review the codes that allow soil overburden loads to be input into the model. Another question here. If I'm using a different product, if I'm using Caesar, for example, can I do this interoperability with STAAD?
No, this is a unique capability of AutoPIPE. AutoPIPE is, I believe, the only product that has the capability to exchange data with a structural product. So if you wanted to kind of leverage this technology, AutoPIPE's really where it's at.
Okay, continuing on. I have a user that is asking how do you do seismic analysis in the AutoPIPE software?
Yeah, we've got static seismic loading, and we also have dynamic seismic loading to a plethora of different codes. I don't have them off the top of my head, but we do have many different seismic loads, static and dynamic, for you guys to choose from.
Okay, let's see, continuing on. Does AutoPIPE have the B31J code, and is it a separate charged module, or is it included?
So B31J was actually included in version 11.0. It's a technology preview because at that time the document was not released to the public. That document has since been released, and my team is currently working vigorously to get the calculations updated based on that released document to be able to make that a commercially released enhancement. But that module is included for free. There's no separate charges. It's included with the standard advanced and nuclear editions of AutoPIPE.
Okay, and the same user, along the same lines, you mentioned the PipeLink tool. Do users have to pay for that PipeLink tool?
So no, the integration between STAD and AutoPIPE is included for free again with all 3 editions. So it's just a feature that is readily available and waiting for you guys to take advantage of it.
Okay, with PipeLink, you kind of ran through it, but can you explain a little further the process to link the pipe points to the structural steel and actually make that connection?
So basically what happens is you first export the piping to STAD, and then STAD brings that piping in, and then within STAD they make the connections. They ensure that the connections are within its range and look realistic. And then when the STAD designer exports those loads, those connections are already there, and when they come back into AutoPIPE, those connections are brought in from basically what the STAD user assumed. You can review them and see if there's a closer node. There's also a module that kind of searches a certain area around that support to make sure that it's picking the right spot within the structural steel. And then within the support dialog in AutoPIPE, there's a spot which says, what is this support connected to? Is it rigid, or is it connected to another node within the software? And that's where you put in that connection, that enables those calculations to use that rigidity or the stiffness of the steel.
Okay, very good. And there is training documentation available on the Bentley Learn server for that integration that goes into detail and goes through an example of actually working through a model. We have a bunch of questions coming in. So another one, how does AutoPIPE detect deflected pipe large displacements that occur in the piping model, and can you export the deflected shape of the load combinations with the high deflections to a file?
So yes, all of our deflections can be exported to a text file or into an MDB file or through the SQLite database with the AutoPIPE report manager. Whatever the deflections are calculated to be, whether they're small or large, it makes no matter what is presented there. Just keep in mind that most of the calculations are assumed to be for quote-unquote, small deflections. So if you're having some large deflections in your pipe, there's probably some sort of issue with your model, so you should probably be investigating those kinds of things.
Okay, I have a question from a user about the version of AutoPIPE that you use. He's saying that your version, the interface that you're using, looks different from the one he's using. Can you explain why?
Yeah, so you probably just haven't updated to the latest version. The version that was demonstrated here was version 11.0. It's basically we released it a couple months ago, and if you guys are up to date on your select service fees, you guys have free access to downloading and updating to the latest version of AutoPIPE. So we will be releasing our next version in the next few days, so be on the lookout for that, so you can update to version 11.1.
Okay, the user that was asking about the soil overburden loads is just mentioning that the soil overburden box is not activated at the bottom of the soil properties edit input, and he's asking why. If you'd like me to answer, I would just say it's probably because of the code that you're using. Luke, I don't know if you have anything to add, but again, the soil overburden is only available in certain codes to actually add into the soil properties. Right,
and we are looking to expand that to more codes. That is on our backlog of features to implement. But yeah, as Jessica stated, if it's grayed out, then you're probably using a code that does not have that capability.
Okay, continuing through these questions. What is the size limit for the models with the STAD interop, and how many connections can be imported into STAD?
So AutoPIPE has a capability of up to 10,000 nodes. So you've got up to that limit, essentially, and the number of supports, there's not really there's probably, I think there's like a 5-character limit for the number of supports, so I bet you hit the limit on your nodes more quicker than you hit the limit on your supports.
Okay, user question. How can the piping and steel interference be checked in the combined model?
So basically, you can just check to see what your deflections are and verify nodes aren't crossing into boundaries of other places. But there's actually the easiest way is to just export a DGN file to Bentley Navigator, and within Navigator you can do what's called a hot clash detection. We call it a visual detection because you're basically having to look to see, do the deflections within the software look like they're crossing. Now that most of the deflections within AutoPIPE are excessive, like they're made to look larger than they actually are, and that's on purpose so that the modeler can see those deflections easier. So you can just do that visual detection to see, okay, this pipe is crossing this beam. Let me go in and check the deflections manually to see, is that deflection of the pipe really going to hit that structural steel? And that's how you do the visual detection. But if you want to do the actual clash detection, that would be the best option, would be to export the DGN file to Bentley Navigator and then do the clash detection from there.
Good. Another one, what will be the approach for wetland?
So for if you're trying to do buried piping with wetland, we do have the calculator for that, but really for those kinds of situations you really have no idea what amount of water is in that type of soil. So you might have to just get some kind of tests to figure out what those soil properties are so you can import those manually.
Okay, a question here from a user. If I create a 3D piping system in AutoPIPE, can I internally generate 2D plan and elevation views, or do I have to export the project to another program such as MicroStation or AutoCAD?
So AutoPIPE does have the ability to create isometrics, but not really 2D plan or elevation views. I think with the isometrics, you can create those in OpenPlant Isometrics Manager, that's where all the isometrics are created. So that's kind of the nice thing about the stress isometrics that are created. They're smart drawings where it's an actual 3D image within the isometric. So it's not just a flat drawing with a bunch of lines like some of our competition's stress isometrics. So yes, within OpenPlant Isometrics Manager, the 2D plan and elevation drawings may be possible, but I couldn't speak to that for sure, but we can definitely find you the answer from our OpenPlant Isometric Manager team.
Okay. Another one is, will AutoPIPE exchange wind load data between AutoPIPE and STAD Pro?
So the wind loads are very similar in AutoPIPE and STAD. So the wind load that they do in STAD Pro will figure out if that steel will fail or pass the loading criteria needed for the steel structure. But AutoPIPE does not bring in any of that wind load data. All we bring in from STAD is the structural steel. AutoPIPE does have its own wind load in it, and in version 11.1, which is coming out in a few days, we've actually added the ability to apply that wind load to the structure that's within AutoPIPE. So that is a feature that's coming out in the next few days.
Okay, here's a good question for the integration between AutoPIPE and STAD. When you export the piping, can STAD see exactly what piping supports are considered at each location? For instance, if it's a resting support, a guide, a line stop, and will it apply the proper restraints in STAD?
Yes, yeah, it'll take all that stuff into account. Basically, what it does is
And then
the loads that the pipe has, like the forces in X, Y, and Z, those loads are applied to the nodes in the STAD model.
right, so it can't see the actual type of support, but it can see the direction that it would need to be supported in based on those loads.
Correct.
And then the continuing with the question, the second part is, can the stress analyst modify these supports after that?
Yeah, there won't be any modifications in STAD, but yeah, AutoPIPE can modify those supports as needed. If the steel needs to be more or less, or the steel can't handle that type of support, then yeah, you can modify your model, and then you can keep sending it back and forth between the two designers. And the nice thing is that's, instead of having to modify drawings and those kinds of things and writing it down, it's, again, just creating that file, which takes, sometimes less than a minute, and then telling the other engineer where that file is so that they can pick it up and put it into their model. It really does save a lot of time.
Okay, good. Continuing on, we'll have time for a couple more questions here. Another one is, I'm working with an owner who has a version of Caesar from 2015, and I'm using the latest version and can't open up his legacy files. So can AutoPIPE open files from any product, or what are the restrictions?
Yeah, so AutoPIPE has the ability to basically save back to a previous version. So say you're using version 11 and you need to send some files to somebody that's using version 10. There's a way to save that model from a version 11 as a version 10 file so that those guys can open it and use it and modify their stuff. And then any of the newer versions can open up any of the older versions of the software. It's really just, if you're using a newer version, you have to save it as an older version's file format to ensure that there's no loss of data, because we've added new features and new capabilities, and so if there's that older software is trying to find all that data, it could cause some issues. So yes, we do have that ability to open up files no matter which version of AutoPIPE you're using.
Okay. Will AutoPIPE consider upheaval buckling?
We do have that on our backlog. That's for the buried piping, and so whoever was asking for that, if you could just make sure you send us that request so I can add your name to the list, and I can prioritize that request a little bit higher depending on how many more people are asking for that feature.
Okay. For AutoPIPE, is there a demo version available of the program, and how much does it cost to get a trial of the program?
Yeah, like I said, if you go to that website, www.bentley.com/AutoPIPE, we do have a free 30-day trial, and trial demo, same thing. And so just go to that website and sign up for that free 30-day trial, and you guys can start kicking the tires of how good AutoPIPE is.
Okay, good. We're going to finish with just one last question here. Can I import the structural steel directly from OpenPlant with the piping instead of through STAD?
No, it's got to come through STAD. So probably the best way to do that is to go through ISM into STAD and then STAD to AutoPIPE. We are working to provide the ability to bring steel in from ISM, which is another great product that Bentley has, and you'll be seeing that in the near future. You should see that by the end of the year.
Okay, great. Thanks, Luke.